Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hello and welcome back to this amazing channel Geeks for Geeks Practice. This is Abhinav, the SA mentor at Geeks for Geeks. Today we are again here with a new problem of the day, which is check if all levels of two trees are anagram or not. Hi Subham. So guys, please write a 1 in the chat if my voice is clearly audible and if I'm clearly visible to you all. And then we will start with the problem. Hi, hi. Great. Hi Subham, hi Rishit. Hi Saujanya. Hi Joel. Hi Suniti. Okay, great. So let's start. Also, guys, before starting, I have a update for you guys, a career update from my side. That this summer I'm going to join LinkedIn as a SD intern. So that was a quite good update from my side. So I just wanted to share with you guys. Yeah, let's start with the problem. Thanks, Suniti. Uh, Okay, great guys. So the problem is here. Let me share the problem link too. Okay, I've shared the problem link. Thanks, Shubham. So let's start with the problem. Uh, sure. पार्टी जब भी मिलते हैं. Thanks. So yeah, let's come to the problem. The problem is that check if all levels of two trees are anagram or not. So we have binary tree basically, and we have to check each and every level of two binary tree. We have to compare the levels, and then we have to check whether they are anagrams or not. Now, what are anagrams? So just like we have anagram strings. Sure, party hogi. So yeah, we have binary trees. So what are the level by traversal? So let's take. So if I will just take the same image which is given to us. Thanks, Ojan. Which is this one. And if you will see here, this is the level 1. Let's say this is the level 2. This is the level 3. Okay. So if you will see one thing here, that in this level from here we have 1. Here also we have 1. In the second level, we have 2 and 3. Here also we have 2 and 3. Here we have 4 and 5. Here we have 4 and 5. So you can see that they all are equal. What is anagram? Anagram means that characters should be same and frequency of each character should also be same. This is what anagram is. Let's say we have 1 1 3 2 and we have 2 1 1 3. They are anagram. Because if you'll see that the frequency, 1 is present 2 times here also, 2 is present 1 time here also, 3 is present 1 time here also. So the characters are also same and frequency of each character is also same. That is why they are anagram. They are anagrams. Okay. Now the only thing we have to do is that's just like we do level order traversal using PFS, using Q. Just similarly, we have to just go on exactly, Subham, exactly. That is what we have to do. So we have to just go on and we have to check that whether the levels are anagram or not. Whether the levels are anagram or not. So let's see. If we will see one thing here, because here we have two roots. We don't have the single root, we have two different roots. So we have to perform this thing with the two different roots. Okay. So the very first base conditions. What are the base conditions? Let's talk about it. Yeah. So base condition is that the very first is that if not of root 1 and not of root 2. That means both root 1 and root 2 means both the trees are just null trees. They don't have any node. So in that case, we will simply return true. Why true? Because obviously, if there is nothing in the both the roots, they are anagram. Okay, obviously. Is it clear? Now, let's say one tree is, uh, we can say null, and another is a not null tree. In that case, answer will be false. So, if any one of the both, then answer will be false. Is this thing clear to everyone? Is this thing clear to everyone? Each one of you? Just write a one. Okay. Now guys, let's forget about the two trees. Now let's just find the in order traversal of a single tree. Let's say of root 1, of tree 1. Let's find for it the in order traversal. Okay. So how we can find it? How we can do it? Obviously, we take a queue. Okay. So let's take a queue of node and let's call it q1 because we have two trees, so we will have two queues at last, obviously. But for now, let's call this one as q1. Okay. That is the very basic thing that we basically do in our level order traversals. Then what we have is in this q1, initially we will push the value of the root 1. Okay, that is what we will do. And now what happens is that while this q1 dot is empty is false, while it is not empty, we just take a value. Then what we'll do, we find the size of it. So I'm saying it's size 1. And then we remove these much of elements from it and take it in a different vector. Is it clear or not? This is the normal level order traversal what we have. So we have to remove this much of trees and then we will have. So you will be mentored at GFG, right? And also I'm able to get also with your link. Okay. Okay, Subham. So let me tell you how it is working. So let's say that this is a queue. In this queue, first we have inserted this one. So this is the one what we have. Now what I will do, I will remove this one from here and I will add all the childs of 1. So 3 and 2 will be added. This is the next level. Now this 3 and 2 will be removed and all the childs of it will be added. This is how the recursion will go on. This is how the recursion will go on. Okay. So that's what basically happens. So we have this queue. Now, while size 1 minus minus, what we will do? What we will do basically. Okay. So we will do level order, no, not in order. We will do level order reversal actually. Okay. Yeah. Okay. So what we will do? We will just take first of all. Okay. First of all, what we will do? I will take let's take it as front one. I will take the front node of it, which is q1 dot front. I will take this node. After taking it, I will take a vector here. Let's call it vector vector int, and let's call it level 1. I will add that to the level 1, means on that vector. Okay, which is nothing but the I think the data of this node. Okay, and after that what we will do, we push the, what I have told you, that after that we push the childs of it into the queue. So before pushing, we have to check that if front one left is present, if it is present, so push it into the queue. And similarly, if its right is also present, push it. Okay, this is the next thing that we will do. And here we are making, or let's make it here like it should be while, and here we will decrease the size, that yeah, we have removed one, size 1. Okay, now so this is what, so in this vector what we will have, in this vector we will have the level order traversal of the tree 1, the level order traversal of the tree 1, but we want level order traversal of both the trees. Yeah, sorry. So now we have to do q1 dot pop. Thanks for it. Thanks, yeah. Okay, thanks. We have to do q1 dot pop. Thanks. Now, guys, this same thing has to be done for two different trees, tree 1 and tree 2, obviously. Two different trees. Okay. So what I will do, yeah, yeah. Actually, that we have to do for the pop is also there. Exactly. Great. So now what I will do, I will take one more queue, which is q2, in which I will push root 2. Okay. Now I will have one more int size 2. Okay. And here I will do and or let's just do it true here, and I will break it afterwards. Okay. And q2 dot size. Okay. Now guys, if size 1 is equal to 0 and size 2 is also equal to 0, that means that both the queues are empty, and we have to return the thing which is, or basically we have to break. Basically we have to break out. Okay. After that what we have to do is, else if size 1 is not equal to size 2, so we have to simply return false. Why false? Because as I told you, to be an anagram, obviously if two different vectors or queues are anagram, that means that should contain same number of elements. But if the size is not same, it's written false. Okay. But if the size is same, we will just go on. Okay. Now guys, here similarly I will have a level 2 also. In this level 2 I will store the level order traversal of the second, and it's fine. Now this same thing will be copied, but for, so I will have 2 here, I will have 2 here, I will have 2, 2, 2, Two, two. Just please tell me if anything is left. Is everything replaced? Is everyone is replaced to 2? Just please tell me. Is it okay now? It is fine. Okay, great. Now, guys, after having this loop to be run, what we will have is key. Okay, yeah. Exactly. Thanks, yeah. Thanks, Ritik. Thanks, Ritik. Thanks. And after that, we have to compare these two vectors. If these two vectors are equal, that means they are anagram. If these two vectors are not equal, that means they are not anagram. So guys, for comparing two vectors that they are equal or not, what we can do? We can either sort both of them and then compare directly, or we can compare their thing using map. Or obviously we can have the frequency of each and every character using map, but map will take extra order of n time space complexity. So what we can simply do is we can simply take a sorting function. So what I can do, I can simply sort these both the vectors. So let's write level 1 dot begin comma level 2 dot end. Okay, and similarly we have to do for level 2 also. And obviously if they are anagram, so they should be equal, and if they are not equal, that means we have to return false. That means we have to return false. Okay, else if this for this complete code is all we run, at the last we will return true. Let's compile it. Yeah, for this it is giving a right answer. Let's try to submit it. Okay, yeah, it has passed. So guys, here in place, because this is sorting is happening here, so it will be order of n log n time is basically taken here. Okay, it is also given here, but we can also do it in order of n. How it can be done in order of n? What I can do, I can take a map here. Let's do that thing also. What I can do is it this thing clear now? Means we are sorting it and then we are making it. Now the next thing what we can have is we can have a map here. Okay, maybe there is some corner case left, Kishore. Maybe. Now what we can do, instead of sorting, what I can do for the first map, you can check it once more, Kishore. Okay, maybe some corner case is lacking, and for each value of it, we will update the map. Okay, and the same thing we will do for level 2, and for each value of it we will decrease the map. Now we will simply traverse to the map. We can simply traverse to the map, or we can simply compare the size, I think. So if map dot size is greater than 0, if it is, so we will return false, because equal characters should be there. So whatever we are adding should be subtracted. At the last it should be minus. Maybe it should work, I think. This should be, I think, something. Uh, so here I think what there is one thing that when we are comparing this map, na, We have to check for each and every index of that map, and maybe it will give a TLE. So let me just check it. Otherwise, we will. Let's check. Yeah, I don't know if it will give TLE. Maybe I'm not sure. Okay, it runs. It runs. Okay. So yeah, guys. So the first submission that we have done, where we were sorting the array. So the first was where we were sorting both the vectors. For that, the time complex and space complex. Time complexity was order of n log n. Okay, and space complexity was order of n for that queue. And for second, which is using hashing, the time complexity decreases to order of n. And I think space complexity is something 2n. Means extra map is basically taken. Na? So that is what we were doing here. And this is how we have just done the problem. Okay. I hope this is clear to everyone. Okay. Okay, guys. I hope this was. Just tell me if it is clear. It was a simple level order reversal. Okay. Or you can say BFS, a breadth first search was also there. Using Q, it has been done. Hmm. Okay. Please tell. Great. Great, guys. Then. Okay. Then we will meet tomorrow with. So, guys, we will meet tomorrow with the next part, which is nothing but the tomorrow's problem of the day. I think that's something LCM. Yeah, I haven't solved it yet. Okay, obviously I will solve it tomorrow. Okay, I don't have to tell that, na. It's actually LCM. So actually, one day someone asked me on LinkedIn that, sir, do you have the list of all the problem of the day? What is going to be sailed in Geeks for Geeks? मैंने कहा no, I don't have. और what you are expecting, I will share that shit with you कि भाई अगले हफ्ते कौन सी पीओडी आने वाली है नहीं. Okay, guys, then thank you very much for joining today's live. Hope it was good. Let's meet tomorrow with the next problem of the day. Till then, thank you. Bye bye. Good night. uh, have a good day for tomorrow. Happy coding. GFG कर लो, हो जाएगा.